All right, so this lesson is on the quadratic formula. The quadratic formula exists because we cannot solve all quadratic equations using factoring. Not everything's factorable. We don't always get whole numbers or integers or fractions for answers. Sometimes we get irrational numbers. Sometimes we get imaginary numbers. So we're going to spend a couple of lessons going through and learning how to use this. So basically what this is they've completed the square on some things and rearranged the equation. And this gives us a formula to find x. It does give us two answers if there are two answers using the plus or minus symbol. You solve it once with the plus and once with the minus. So the main formula is the opposite of b, plus or minus square root of b squared minus 4ac all over 2a. And I'll show you how that works here in a little bit. Okay, so it's used to find the solutions to a quadratic equation of the form ax squared plus bx plus c. So that's where the a and the b and the c come from. It's used to find the x intercepts of a quadratic function of the form ax squared plus bx plus c.
Is that intercept?
And intercepts, sorry, I couldn't get it squeezed in there very good. It is intercepts. And then the terms, down here it just says note the terms zeros or roots are sometimes used for those solutions, those x-intercepts. There's a lot of different words that you're going to see. And I tried to make the directions slightly different on each one of these so that you could just kind of get used to the fact that you're doing the same thing on all of them, even though they're asking you for different things. So the first two problems could be solved by factoring, but I'm going to use them because they have easier numbers so that we can look at the formula and get used to it. And then on the rest of these, we're going to see some decimals, some radicals, that sort of thing. All right, so you guys all got your blanks?
Yeah.
Okay. So over here, it's got our objective. We're going to solve quadratic equations using quadratic formula. That's what we're doing. And the directions on this just say solve. And they have this equation that's equal to 0. So we're going to go through and use the quadratic formula. So a is always the number that is in front of the x squared. So I'm just going to write down that a is 2. B is always the number in front of x, which is 5. And then c is the constant on the end, and then that minus does go with it. It's negative 3. And we're going to put that into our formula. So that formula is negative b plus or minus. You don't have to write it again because you have it on your papers. But I'm going to write it out just so you can see it while I'm working this out. So opposite of b plus or minus square root of b squared minus 4ac all over 2a. So this, I call it opposite of b because if this is positive and you put it in there, it's going to become negative. So negative 5 plus or minus the square root. I'm going to have 5 squared minus 4ac. So 4 times 2 times negative 3 all over 2a. So 2 times 2. Okay? And what you want to do at this point is you want to figure out what's inside that square root. And you can just use your calculator if you want to type all of that in. And we end up with, I wrote equals instead of plus or minus. I have negative 5 plus or minus the square root of 49. And on the bottom, 2 times 2 is 4. So 49 is a perfect square. We can go ahead and do that. This would give me negative 5 plus or minus the square root of 49, which is 7 over 4. So you're going to get two answers. The plus or minus is telling you you're going to solve this twice. The first time you're going to add negative 5 plus 7 is 2 over 4, which reduces to 1/2. And then negative 5 minus 7 is negative 12 over 4, which reduces to negative 3. And that gives us the two answers. The quadratic formula will work on any quadratic, even if your answers are imaginary, if they're fractions, anything. Factoring does not. So that's the biggest reason why we have this. It is kind of an interesting formula because there's so many pieces, but it's just a fail-proof way to get your solutions. Now, remember, you can check your solutions by putting these in for x and just making sure that you get 0. So you could check that really quickly with the calculator if you wanted to. Okay, so let's go down and take a look at the next one. So on the next one, I took the same equation and then changed some of the signs. So on the next one, A is going to be 2, B is -5, and C is 3. All right, so lots of good math conversation happening. I like it. All right, so here's our formula again. I'm just writing it in the corner so we have that to look at. If I have -b or opposite of B, and B is already negative, what's going to happen? Positive. So we're going to get +5 plus or minus square root. And when I put -5 in to square it, if you're using a calculator, you want to put parentheses on that, because that's always going to come out positive. And then -4 times A, which is 2, times C, which is 3. Sometimes they'll put everything in parentheses that you put in. It just makes it safer. And then I will have 2 times 2 on the bottom for the 2A. So I will get a different number in here. This will be 25 minus 24. So it's going to give me the square root of 1. And then this is over 4. So I'm going to have, I don't know why I did that. I can just put an equal sign. So I'm going to have 5 plus or minus 1 over 4. So for the first one, I'm going to do 5 plus 1, which is 6. So I have 6 over 4, which is, you can just write as 3/2 if you want, or 1.5, or 1.5. And then the second time, 5 minus 1 is 4, so 4 over 4 is 1. Now you're going to want to pay attention to directions, because sometimes they're going to tell you they want decimals. If they want a decimal for this, I would go ahead and divide it and write down 1.5 as my answer. If they say they want it in exact form, then you're going to want a fraction, either 3/2 or 1.5. So you just have to pay attention to directions on the assignment. Half of it is decimals and half of it's not, and so we'll talk about that a little bit more on the next one. All right, so going on to this one. It says find these solutions. That means the same thing as solve. And then here's our equation. So A is 3, B is -4, and C is -1. And I'll write the formula up here again, just so we have that in front of us and you can see it while we're working. So opposite of B, but B is negative, so negative makes positive. So that's going to make it +4. So think of this as just changing the sign on B. Plus or minus the square root, B squared would be -4 squared minus 4 times A, which is 3, times C, which is -1, all over 2A would be 2 times 3. If I find the number that's underneath the square root, so I might just type in -4 squared minus 4 times 3 times -1, I will get 28. So I'm going to have 4 plus or minus the square root of 28. It's actually, if you just look at it, it'd be 16 plus 12, so that's where that comes from. And then it's over 6. This is not a perfect square. So what we're going to do at this point depends on if they want decimals or fractions. If they want decimals, what you're going to do is you're going to type in 4 plus the square root of 28, get that answer, and then divide by 6. And if I do that and I'm doing decimals, with the plus, I get 1.55. And if I do the minus, 4 minus the square root of 28, then you want to hit enter, have that answer, then divide by 6, you'll get -0.22. And so if they're asking for decimals, you can just type this in, figure out what it is, add 4 to it, divide it by 6. But the key is you got to figure out the whole top, hit enter before you divide by 6. So if you want to take a second to put it in the calculator, make sure you can't just type it all in one shot. You want to do the top, hit enter, divide by 6. So the first one was with plus, the second one is with minus. And so if it wants decimals, that's what the answers are going to look like. If it wants exact form, it'll want a simplified radical. So you would do 4 plus the square root of 28, and you'd hit enter, and then you hit divide by 6. And you get 1.55.
Yeah.
Okay, and then you do the same thing with minus to get the other one. All right.
But if they don't want decimals, 28.
If they don't want decimals, then I have to simplify the square root of 28. So we're going to birthday cake it. So you take 28, divide by 2, you get 14. Divide by 2, you get 7. Divide by 7, you get 1. And so I would have 2 squared there. And so I could take this and rewrite it as 4 plus or minus 2 radical 7 over 6, which you couldn't see because I just went off the screen. So what I did was I simplified the radical, so I get 2 radical 7, and I replaced that. And you can simplify it more, but it's an all or nothing. The 7 stays. It's inside the radical. It's trapped. But the 4 and the 2 and the 6 can all be divided by 2. So you can do 2 plus or minus the square root of 7 over 3. And technically, that is your positive and your negative answer.
Wait, how did we
They just write it.
How did we just get the 2 plus or minus square root of 7?
So the 4 and the 2 and the 6 all divide by 2.
Oh, God, okay.
So basically, you either have to reduce all 3 of those numbers or none of them. They all have to divide by the same number. But this is both answers. So if you can do the simplifying of the radical, once you get done, both answers are kind of together. They just write it in this little compact form. All right, so let's take a look at the next part. We're about halfway. It's going to go a little faster because now we know what we're doing, kind of. So over here, we're going to find our A, B, and C. I just like to write those down so we know what they are. So A would be 3. That's in front of the x squared. B is 2. And then C is negative 3. And then our formula is negative b plus or minus square root b squared minus 4ac over 2a. So I'm just going to have that formula kind of sitting over there so we can look at it. So negative b be negative 2 plus or minus big square root. I'd have 2 squared minus 4 times 3 times negative 3. And if you want to put all that in parentheses, you can.
I done did it.
And then it's over 2 times a, so 2 times 3. So what you want to do first is figure out what's underneath the square root. And you could just type in 2 squared minus 4 times 3 times negative 3 on your calculator. It'll do all of that really quickly. Or you could sit there and go, okay, that's 4, and that's going to be plus 36, and you end up with 40. So I have negative 2 plus or minus the square root of 40 over 6. So if they want decimals, we can just type in negative 2 plus the square root of 40, hit enter, get the answer, then divide by 6. And if you do that, you get 0.72. And you do the minus one, you get negative 1.39. I think those are round off.
If they don't want decimals, it's 2 square root of 10.
Yeah, if they don't want decimals, then we have to simplify the radical, the square root of 40. So I'll do that down here really quick. So divide by 2, you get 20. Divide by 2, you get 10. Divide by 2, you get 5. Divide by 5, you get 1. So I'm going to have a 2 squared we could take out. And so that square root of 40 becomes 2 radical 10. You were right. Over 6. Can I reduce it?
3.
Yeah. So can I reduce? So can I reduce this fraction?
Oh yeah, by 2.
By 2. So I can make this negative 1 plus or minus radical 10. And something that sometimes comes up, if you want to make that 1 radical 10, you can. And we're going to put that over 3. And this takes care of both answers. And this is considered to be exact form. And we wrote it in simplified radical form. So if it asks for exact form or it tells you it wants simplified radical form, you're just going to do that radical. You guys have had lots of practice with simplifying radicals, so I don't think that's going to hang you up too much. And you will not have to do both of these on the same problem. I'm just kind of using the same problems for both. Okay, so one more of these, and then I'm going to show you something a little different. So on the next one, let's see, A is 5. B is negative 2, and C is negative 1. Make sure if there's a minus, it goes with the number that comes after it. I'm going to write out my formula again. Just as a tip, if you have trouble memorizing formulas, and this is one that you would want to know for like ACTs and SATs, it's just nice to know. It can help you out a lot. Write it every time you do a problem, and by the end of an assignment, you pretty much have it memorized. That's the best way to do that. All right, so it says negative B. B's already negative, so we're going to change that to opposite and make that positive 2 plus or minus square root of negative 2 squared minus 4 times 5 times negative 1. If you are using your graphing calculator, that negative 2 must go in parentheses.
Why is it negative 2 squared, not negative 1 squared?
Because it's b squared, and b is
wait,
negative
b
2.
squared.
And then it's 2 times a on the bottom, so 2 times 5. So we've got it set up. If I do the math that's inside the radical, I get the square root of 24. 2 times 5 on the bottom is 10. So for the sake of time, if we are looking for decimals, you're just going to use your calculator, type in the top, get the answer, divide by 10. With the plus the first time, minus the second time. You're going to get 0.69 for one of them and negative 0.29. And that would just be using your calculator. If I reduce this radical, I get 2 radical 6. So I just did that in my head. You can use the birthday cake method if you want to. And I get 2 plus or minus 2 radical 6 over 10.
1 plus or minus 6 over...
Radical 6 over 5, yes. So we can divide all of those by 2. And then that gets us the exact form, or the simplified radical form,
Let me guess,
depending on what they ask. Okay, nope. So I'm going to show you a couple of things, just little twists on what we're looking for. On the next piece, it asks you to find the x-intercepts of the graph y equals, and it gives us this equation, round to the nearest tenth. It says nearest tenth, they obviously want decimals. But if we are doing x-intercepts, when you want x-intercepts, that's where the y is 0. So you're just going to put 0 in and do exactly the same thing that we've been doing on the others. And so if I just have negative x squared, that'll make a negative 1, b is 5, and c is 2. And we put it all into the formula. So negative 5 plus or minus square root of 5 squared minus 4 times negative 1 times 2 all over 2 times negative 1. If we do the math that's inside the radical, we'll get negative 5 plus or minus the square root of 33 over negative 2. 33 is just 3 times 11. It doesn't simplify any further. The only thing you could do with this if they wanted exact form was get the negative out of the bottom. And you do that by changing all the signs. So this becomes positive. The plus or minus, it just is still plus or minus because you need both. And then over 2. So if they wanted exact form, this is what we're looking for. But they're actually looking for nearest tenth. So we would type this in, and you'll get negative 0.4 and positive 5.4. And so what we just found is that if we were on the graph at negative 0.4, and over here at 5.4, this parabola would touch the graph. And since the beginning of this is negative, I know it opens upside down. And so we'd have a graph that kind of looks like this. And so when they're asking for x-intercepts, you're just looking for where it goes to the x-axis. And you can totally find that using this formula. So it's useful for lots of things. And we used this last year a lot for story problems when we were doing those projectile problems and we were trying to figure out when it hit the ground. We were looking for this point over here. Okay, so let's take a look at the last one. The last one just has a slight twist. Can you see what it is?
You
Got to subtract the 7. You have to have it equal to 0, just like we did when we were using factoring in the zero product property. So you want this equal to 0. I can't use the positive 7 because it's on the wrong side of the equation. Got to move it over here. And that makes A1, B3, and C negative 7. And then we can put it all into the formula. So negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 7 all over 2 times 1. So when we put that all in, we're going to get negative 3 plus or minus the square root of 37 over 2. If they were looking for the exact form, 37 is prime, I could stop there. There's nothing I can do to simplify that or reduce the fractions, so that's kind of nice. If they want decimals, you type it in the calculator, you'll get negative 1.54 and negative 4.54. So it just depends on what kind of an answer that they want.